When exploring other planets in our galaxy, one of our primary goals is to identify planets with surface liquids and the right conditions to support life, similar to Earth. Over the past decade, we have launched advanced telescopes, such as the Kepler Space Telescope, to find Earth-like planets orbiting nearby stars. These efforts have led to the discovery of many planets resembling Earth. For example, since its launch in 2009, the Kepler Space Telescope has identified over 4,000 Earth-like exoplanets in the Milky Way. Some of these planets have a higher potential for hosting life than others. Recent research suggests that certain planets might offer conditions even more favorable for life than Earth, earning them the classification of super-habitable planets. How are these planets discovered? To identify them, researchers applied specific filters to the planets we've already discovered. After applying these filters, only 24 planets qualified as super-habitable. What were the filters? First, a planet had to be rocky and located within the habitable zone of its star. Planets orbiting stars that were not G-type stars, like our Sun, or stars that were too young were excluded. Younger stars emit stronger solar winds and radiation, which can be detrimental to life. Interestingly, researchers included planets orbiting cooler, less massive, and dimmer stars like orange and red dwarfs. While these stars aren't as ideal as Sun-like stars, they have a significant advantage. Their lifespans range from 20 billion to 70 billion years. In contrast, Sun-like stars have a lifespan of about 10 billion years, and our Sun has already burned through roughly 4.6 billion years, leaving only about 5 billion years. Although 5 billion years may seem like a long time, humanity has only about 1 billion years to find a way off Earth. This is because the Sun's brightness increases by about 10% every billion years, which could end life on Earth and evaporate its water. On the other hand, it is estimated that Earth's current level of life took approximately 3.9 to 4.2 billion years to evolve. Fossil evidence shows that humans emerged only in the last 300,000 years of this timeline, and our technological advancements have occurred within the past 200 years. This timeline highlights how short 4 billion years is for the development of intelligent life. If life had started on a planet orbiting a red dwarf, there would have been significantly more time for evolution and advancement. Planets in the habitable zones of red or orange dwarfs could therefore have a substantial advantage over Earth. For a planet to qualify as super-habitable, it also needs to be slightly larger and more massive than Earth. This would provide more habitable land area, slower core cooling, and stronger gravity, which would help retain its atmosphere for a longer period. These planets should also have minimal landmass and consist primarily of water, creating archipelagos surrounded by shallow seas, which would nearly eliminate deserts. Additionally, a super-habitable planet is thought to be slightly warmer and more humid than Earth. Warmer and wetter environments tend to support greater biodiversity, as seen even on Earth. After applying all these criteria, researchers identified only 24 super-habitable planets. However, many of these planets remain unconfirmed, and further observations are necessary. Still, we do have some data on 2 of these planets, which we will explore this week. Our first destination is Kepler-69c, located approximately 2,383 light-years away. This planet orbits a G-type star called Kepler-69, completing one orbit in 242 days. Initially, scientists suspected Kepler-69c was a dry and uninhabitable planet like Venus, as its distance from its star is similar to Venus' distance from the Sun. However, observations revealed that Kepler-69 star is only 80% as bright as the Sun, suggesting that Kepler-69c is within the habitable zone. Kepler-69c is a rocky planet about 3.5 times the size of Earth and likely has a dense atmosphere. A thick atmosphere is crucial for protecting against harmful ultraviolet radiation, which could otherwise hinder the development of complex life. A strong atmosphere also moderates temperature differences between day and night, unlike Mars, where temperatures swing dramatically between 70 degrees Fahrenheit during the day and minus 195 degrees Fahrenheit at night. Additionally, a robust atmosphere facilitates the movement of elements across the planet and supports water and carbon cycles, which are essential for ecosystems. Without such an atmosphere, life on Kepler-69c might resemble simple organisms like tardigrades, which can survive extreme conditions but lack complexity. Temperature is another critical factor for life. For carbon-based life to exist, liquid water must be present, requiring temperatures between 32 degrees Fahrenheit and 212 degrees Fahrenheit. At first glance, Kepler-69c appears too cold for liquid water, with temperatures ranging from 23 degrees Fahrenheit at its closest point to its star and minus 40 degrees Fahrenheit at its farthest point, resulting in an average temperature of minus 13 degrees Fahrenheit. However, a thick atmosphere could create a greenhouse effect, warming the planet to temperatures suitable for life. For comparison, Earth's average temperature would be 0 degrees Fahrenheit without its atmosphere, but is 59 degrees Fahrenheit due to the greenhouse effect. If Kepler-69c has significant amounts of water, it could qualify as a super-habitable planet. However, keep in mind that Kepler-69c is 2,300 light-years away, and our predictions about it could be incorrect. The Kepler Space Telescope has discovered thousands of planets, including 2,400 unconfirmed candidates. Among these, the notable candidate is KOI-4878.01. I will refer to it as KOI in the rest of the video, which has a 98% similarity index to Earth. Observations show that its host star, located 1,135 light-years away, is a G-type star older than our Sun. KI is nearly the same size as Earth, completes an orbit in 449 days, and resides within the habitable zone of its star. Studies indicate that KI's average temperature is approximately 62 degrees Fahrenheit, making it likely to host liquid water. Despite its potential, KI's great distance and small size make it inaccessible with current technology, leaving its true nature a mystery. Don't forget to subscribe so you don't miss my new videos.